Hello students, since last 3 classes we have been learning different methods of integration. As promised, I am back with few more methods of integration. Today we are going to learn integrals of some particular functions, integrals of some more types, integration by partial fractions and integration by parts. By the end of this class, you will know which tool to grab and when. Most of questions that I have taken up are all PYQs. So आपके PYQ यहाँ पे practice हो जाएंगे. Let us start with integral of some particular functions. When we say integral of some particular functions, these are the particular functions we are talking about. There are these 6 particular functions. Now it is not possible that in your board exam you do not get a question based on this or you do not use one of these formulas. You will definitely, most definitely going to be using one of these formulas. And in this section, today's class, what I am discussing, 5 marks will be on your table if you watch it till the end. तो ये जो फर्स्ट वाली आइडेंटिटी है बच्चों, इसमें आप ऑब्जर्व कीजिए कि डिनोमिनेटर में है एक्स स्क्वायर माइनस ए स्क्वायर. इनको याद करने का एक बहुत ही अच्छा तरीका होता है. इसी तरीके से मैंने ये ग्रुप करके लिखी हैं. आई हैव रिटन देम इन अ मैनर दैट यू कैन सी दैट द फर्स्ट 2 आइडेंटिटीज look similar and have a similar answer. The difference is here it is x square minus a square in this direction, and in the second one it is a square minus x square, and the change will happen over here. Here it is x minus a upon x plus a, whereas in the second one here in a square minus x square it is a plus x upon a minus x. Then I have grouped this 4th and 5th together. In 4th and 5th, what happens is under the root you have again x square minus a square, and here you have a x square plus a square, but the answer is similar. And in terms of log of x plus, do you observe that this term is same as this, and here in the 5th one what x is added to is also same as this, whereas this 3rd and 6th are similar. In 3rd and 6th you can relate them to the integral of 1 upon 1 plus x square. Children, we saw in the last section is tan inverse of x, and you can see over here when instead of 1 you have a square, you will have a 1 by a here and tan inverse x by a. That's how it will look. Then this also you can relate to the integral of 1 upon under root of 1 minus x square. That makes it easy to differentiate from these 2 remaining root में जो denominator है उनसे. कैसे इसको आप differentiate कर पाओगे कि ये sin inverse वाला है, क्योंकि यहाँ पे a square minus x square है, तो वो sin inverse x के फॉर्मूले से मैच करेगा. इसका इंटीग्रल होता है साइन इनवर्स ऑफ x प्लस सी. ऑफ कोर्स एवरी टाइम व्हेन वी इंटीग्रेट इंडेफिनिट इंटीग्रेशन में वी ऐड प्लस सी. देयर इज अ जोक व्हिच गोज अराउंड इन मैथमेटिक्स कम्युनिटी अबाउट दिस प्लस सी, that what is this plus c. Children always ask, is it necessary to add plus c? So in the teachers community that goes around like a joke. All right, nonetheless, तो ये वाले आइडेंटिटीज़ बच्चों इस तरीके से आप एक एक पेयर में ग्रुप करके इनको आराम से याद रख सकते हो. The following are some questions which have come across in various year papers. The first one is this. Here, children, you observe the denominator. In this denominator, we will complete the square. Observe that all the formulas are either x square minus a square or x square plus a square. They are not spread like this quadratic polynomial. So when they are not spread like this, we are going to now compact it. तो ये जो x square minus 6x plus 13 है बच्चों, इसको हम completing the square करके लिखेंगे. Completing the square की एक टेक्निक होती है. हम सबसे पहले x स्क्वायर को आप ऑब्जर्व करो, किसका स्क्वायर होता है x का. अब हम आगे फिर मूव करेंगे, क्या साइन है माइनस, तो माइनस लगाएंगे. और आगे मूव किया तो आपको दिखाई दे रहा है 6 को आप डिवाइड कर दोगे 2 से, और अब आप क्लोज कर लोगे ब्रैकेट और उस पर लगा दोगे होल स्क्वायर. फिर आप आगे मूव करोगे, प्लस का साइन है प्लस लगा देंगे, और आगे मूव किया तो 13 मिला हमें. अब हमें करना क्या है, अब हमें ये जो 6/2 कट होके यहाँ पे बन गया 3, तो हमें बेसिकली यहाँ पे माइनस करना है 3 के स्क्वायर से, विच इज़ 9। ऐसा करने से हमें ये होल स्क्वायर कंप्लीट होके मिल जाएगा as x minus 3 whole square, and 13 minus 9 is 4. So what we have done by doing this process is we have completed the square of denominator, and after doing this it will match with one of the types that we have discussed just now. Can you see it clearly matches with the integral of dx upon x square plus a square? Then we know that this was the third identity, which is 1 upon a tan inverse x by a. Note there is plus in between x square and a square, and also note there is no root over here. That is why it is this identity. Now we can clearly identify what is there in place of this x minus 3. What is in place of a? 2. So we will replace it over here, and now we are ready with answer. It is 1 upon 2 tan inverse x minus 3 divided by 2 plus c. Next one, here in this also what we will do is complete the square of the denominator. Here one thing is to be noticed, children, very important, is the coefficient of x square is negative. When the coefficient of x square is negative, we will take the minus sign outside and then we will write the polynomial, which makes it this. Now once we have taken minus sign outside, इस minus को यहाँ बाहर रखते हुए हम इसका completing the square करेंगे. वही same procedure जो हमने पिछले question में use किया था. मैंने अंडरलाइन किया एक्स स्क्वायर को. किसका स्क्वायर होता है एक्स स्क्वायर? एक्स का. अब थोड़ा और आगे बढ़े, प्लस का साइन है तो प्लस लगा लेंगे. अगर वहाँ माइनस होता तो माइनस का साइन लगा देंगे. और इसके आगे गए तो 6 मिला हमें. 6 को किससे डिवाइड कर लेंगे? 2 से. यहाँ पे हम इस ब्रैकेट को कर लेंगे क्लोज और उसके ऊपर लगा लेंगे स्क्वायर. फिर आगे जब आपने मूव किया तो माइनस का साइन आ गया. फिर जब आपने मूव किया तो 7 आ गया. अब ये सब कंप्लीट होने के बाद में इवेंचुअली ये 2 और ये कट के यहाँ पे 3 बच जाएगा. तो ये जो 3 बचा है बच्चों, इसके स्क्वायर से ही हम माइनस करेंगे. तो इसके स्क्वायर से हमने कर दिया माइनस और क्लोज कर ली हमने ब्रैकेट. माइनस इसको बाहर ही मैनेज करते हुए हम ये से लिखेंगे x प्लस 3 का होल स्क्वायर माइनस 16, और ये हमारा हो गया कंप्लीट स्क्वायर. लास्ट में हम क्या करेंगे, ये जो माइनस का साइन है इसको हम अंदर मल्टीप्लाई कर लेंगे. तो जब हम इसे अंदर मल्टीप्लाई करेंगे तो हमें मिलेगा 16 माइनस एक्स प्लस 3 का स्क्वायर. अब हम वापस अपने इंटीग्रल पे आ जाएंगे. ये हमारा इंटीग्रल अब बन जाएगा अंडर द रूट 16 किसका स्क्वायर होता है? 4 का, माइनस एक्स प्लस 3 का होल स्क्वायर. यहाँ पे आपको गौर ये करना है कि जब रूट है या रूट नहीं है. आप देख सकते हो कि यहाँ पे रूट है. तो जब यहाँ पे रूट है तो ये कौन सी आइडेंटिटी हुई? अगर आप कंपेयर करके देखें तो ये अंडर रूट ऑफ ए स्क्वायर माइनस एक्स स्क्वायर की आइडेंटिटी है. जब ए स्क्वायर माइनस एक्स स्क्वायर हम देखते हैं तो रूट में अगर है तो ये साइन इनवर्स एक्स बाई ए प्लस सी से मैच कर रहा है. बिकॉज ऑफ दिस आइडेंटिटी clearly you can see that in place of a we have a 4 and in place of x we have x plus 3. That will enable us to write our answer, and our answer is sine inverse of x plus 3 divided by 4. Such kind of questions are asked for 2 marks. Sometimes it can also be asked for 1 mark, but they are going to be asked definitely. Now if you see this question number 3, children, then it is little different from the first and the second question. Neither it is in any of the standard 6 forms. So when we get something like this, where it is, note, there is a linear polynomial in the numerator and there is a quadratic polynomial in the denominator. Moreover, the numerator linear polynomial is not the derivative of the denominator quadratic polynomial. So substitution cannot work over here. In such situations, there is a standard operating procedure I call SOP, and that SOP is we are going to write down the numerator polynomial as capital A into the derivative of denominator. I am writing the derivative here directly, plus B. And by writing this and comparing the left and the right hand side coefficients of x and the constant term, we are going to get the values of a and b. Now when we compare, we get 4a equal to 1, that will give me a as 1 by 4. Then we will get 6a plus b equal to 2. Then you put a as 1 by 4 which we had already got plus b equal to 2. तो ये हो जाएगा 3, ये 2. So b will be equal to 2 minus 3 by 2 which finally gives you 1 by 2 upon simplification. Thus we have got our a and we have also got b की value. Now we are going to rewrite x plus 2. Now integral now will become instead of x plus 2 we will write a which is 1 upon 4 into 4x plus 6 plus 1 upon 2 upon, write down the same denominator and then we are going to split. उसके लिए हम इसे एक टर्म में ग्रुप कर लेंगे, इसे हम एक और टर्म ग्रुप कर लेंगे और स्प्लिट करने पे ये 1 upon 4 है कांस्टेंट, यहाँ पे मिलेगा 4x plus 6 अपॉन ये हो जाएगा 2x स्क्वायर प्लस 6x plus 5 dx प्लस 1 upon 2, फिर यहाँ पे इंटीग्रल आप यहाँ पे भी dx लिखना मत भूलो, जैसे ये प्लस c का होता है वैसे ये dx को भी लिखना यहाँ पे बहुत ज़रूरी होता है. तो dx शोज़ कौन से वेरिएबल के विद रिस्पेक्ट टू हम इंटीग्रेट कर रहे हैं. तो इसमें बच्चों ये डिवाइड हो गया I1 और I2 में स्प्लिट हो गया है. तो ये जब I1 और I2 में स्प्लिट हो गया है तो I1 क्लियरली आप देख सकते हो कि इसको हम अगर t ले लें सब्सटीट्यूशन से ये वर्कआउट हो जाएगा तो न्यूमरेटर क्लियरली इसका डेरिवेटिव है, dt बन जाएगा 1 to 1 एकदम इस तरीके से ये होता है. और ये जो I2 है बच्चों इसमें हम इसके होल स्क्वायर को कंप्लीट करेंगे और इसके होल स्क्वायर को कंप्लीट करके इट विल कम इन वन ऑफ द 6 फॉर्म्स दैट वी हैड डिस्कस्ड. लेट अस राइट द आंसर फर्दर. सो यू विल हैव 1 upon 4 dt by t plus 1 by 2 integral of dx upon, here we have a choice of taking this 2 out from here, this 2 out from here and then completing this square, or we can leave this 2 here and then complete the square. So let me take this polynomial aside and complete its square. I am writing it here 2x square plus 6x plus 5. इसमें से 2 को निकाल लेंगे बाहर तो आपको मिलेगा x square plus 3x plus 5 by 2. अब इस पॉलिनोमियल का आप कंप्लीट जब स्क्वायर करेंगे तो आपको मिलेगा x plus 3 by 2 का होल स्क्वायर प्लस 5 by 2 माइनस इस 3 by 2 का जो स्क्वायर होगा बच्चों उससे हम इसे माइनस करेंगे विच इज़ 9 by 4. अब इसकी आप सिंप्लीफिकेशन जब करेंगे तो यू विल गेट इट इक्वल टू 2 into x plus 3 by 2 whole square and taking the LCM as 4 you will have it as 1 upon 4. 10 minus 9 you'll get. So this is what we are going to get. अब यहाँ हम डिनोमिनेटर में इसे यहाँ कॉपी कर लेंगे. तो यहाँ इधर कॉपी करने पे हमें यहाँ 2 बाहर रख लेंगे और इधर मिल जाएगा x plus 3 by 2 का होल स्क्वायर प्लस 1 by 4 को हम 1 by 2 का होल स्क्वायर लिख सकते हैं. अब आप देख सकते हो कि इसका इंटीग्रल हो जाएगा log mod t प्लस इस 2 को बाहर 1 by 2 से मल्टीप्लाई करके 1 by 4 हो जाएगा. एंड दिस चिल्ड्रन यू कैन सी इज मैचिंग विथ x square plus a square in the denominator identity which resembles the tan inverse wala identity. Tan inverse is multiplied by 1 by a. So you will have 1 by a tan inverse of x plus 3 by 2 divided by 1 by 2 plus c. Now we are only left to simplify it. ये 2 इससे कट के यहाँ पे 4 से कट होके 2 दे देगा. यहाँ पे आप LCM इसका ले लेंगे ये वाले टर्म का. तो that will make it as 2x plus 3 divided by 1 only. That 2 will get cut. So this is going to be your answer. Next, let us see integrals of some more types. These are 3 more formulae, children, and sometimes a 1 or a 2 mark question is also asked on these formulae. Sometimes your function may directly be in this form or sometimes it may have to be reduced to this form. Out of these, I would like to highlight on the third identity, which says that root of a square minus x square is equal to this. Why I am highlighting this identity is because in application of integrals, children, this whenever you get a circle ka question or there is an ellipse, this formula is definitely going to be used in the next section of AOI, which also carries 5 marks, and 5 marks out of 80 is quite a big number to keep in your pocket. So this formula you need not forget at all. Even if I would say that you do not remember the first or the second formula, you must remember formula 3. The ideal situation is you remember all 3 of them. Now I'll teach you a trick of remembering these 3 formulas. इन तीनों फॉर्मूला को याद रखने की ट्रिक देखिए. ये तीनों में यहाँ पे x/2 है. पहले तो x/2 किससे मल्टीप्लाइड है? जो ये है यही खुद यहाँ मल्टीप्लाइड है, यही खुद यहाँ पे मल्टीप्लाइड है, ये खुद यहाँ पे मल्टीप्लाइड है. फिर उसके आगे अगर आप देखो तो सब में यहाँ पे है a²/2, इधर भी a²/2, इधर भी. ये कॉमन चीज़ है इन तीनों में. बस एक ही यहाँ पे ध्यान देने लायक बात है कि फर्स्ट वाली आइडेंटिटी में बीच में साइन माइनस है, बाकी दोनों जगह यहाँ पे प्लस है, सेकंड और थर्ड में a²/2 के पहले. तो ये याद रखना इसलिए आसान होगा कि जब यहाँ पे x² माइनस a² है तब यहाँ बीच में माइनस साइन है, और एक ही में माइनस है तो कौन सी में माइनस है उसको रूल आउट कर लो, बाकी दोनों में प्लस है. राइट. तो आगे हम बढ़ेंगे तो हम देखते हैं कि यहाँ पे ये इस वाले लॉग ऑफ इस टर्म से मल्टीप्लाइड है, ये इससे मल्टीप्लाइड है, ये साइन इनवर्स x में. तो अगर आप ध्यान दो तो ये जो फॉर्मूला 1 में था तो वो क्या था? वो यही तो था, log of x plus root of, isn't it? So can you relate? This second term over here is, this one is what was there in 1 wala formula. Even this is what was in 1 this ka formula. Even sin inverse x by a is what it was in 1 ka formula. That makes these identities easy to remember. So these are sum of 2 terms. Usually I watch that children in my observation they do not learn the identities, they refer and use. फिर बाद में कभी भी याद नहीं होती. आप हमेशा याद कीजिए identity और फिर उसको use कीजिए. Now this is the kind of question you will get to solve, and here you can clearly see that it is all a matter of completing the square. Also note that the coefficient of x square is negative. In such cases the negative sign first will be taken out and then we will proceed further, keeping the negative sign outside and then completing the square. You get a x plus 2 whole square minus 1. You again subtract it by the square of 2 and the square of 2 is 4. इससे आप subtract कर लेंगे. Then bring this minus sign inside in the end, which makes it this. By now you should be clear about the method of completing the square. This 5 is root of 5 ka square minus this is x plus 2 ka whole square dx. Now clearly it resembles the third identity that we had learned. This will double up as a square and the second term will double up as x square. So for a square minus x square under the root, it said that it is x by 2. What is there in place of x? X plus 2 by 2. Under root of, children, just trail it back what it was. We can write the exact same thing because this only has been rewritten like this. That's why when we rewrite, we can write 1 minus 4x minus x square over here. Then it was added to a square by 2. A square is 5 by 2 sine inverse of x, which is x plus 2 divided by a, which is root 5 plus c, the constant of integration in the end. This is the answer of it. Next, the integration of partial fractions is a very important topic. It is not possible that you do not get a question involving either integration by partial fractions or the previous section that we have seen. So in partial fractions, what is the difference is the denominators are never going to be under the root and they are going to be either a quadratic polynomial or a cubic polynomial like this. Now in quadratic polynomial, children, it is possible that we have two distinct roots like in the first one, and when the roots are distinct and it is factorizable, we are going to resolve it into a upon x minus a plus b upon x minus b. When the roots are repeated, like in the second case, we are going to resolve a upon x minus a plus b upon x minus a whole square for quadratic polynomial. For third one, we have a cubic polynomial in the denominator with three different roots. As you can see over here, we are going to resolve it as a upon x minus a plus b upon x minus b plus c upon x minus c. The cubic polynomial can also have a factorization of this type, x minus a whole square into x minus b. In that case, we resolve it as a upon x minus a plus b upon x minus a whole square plus c upon x minus b. This cubic polynomial also has a possibility of getting a factor linear x minus a into a quadratic, which can then further cannot be factorized. In such situations, you have to be very careful for partial fractions. You will take a upon x minus a plus bx plus c upon that polynomial quadratic, which could not be factorized further. Next, let us see where do we apply this. Here in this first question, can you see there is this denominator x square plus 3x plus 2. Let us check if this can be factorized. So we can clearly factorize it as x plus 1 into x plus 2. So once a quadratic polynomial can be factorized, we will just pick up this polynomial 2 upon x plus 1 into x plus 2. We will rewrite it as a upon x plus 1 plus b upon x plus 2, and after rewriting it like this, compare the numerator 2x to the numerator after taking the LCM over here and find a and b. So the easiest way of finding a and b over here is first we will put x as minus 1. When you put x as minus 1 on both the sides, the left side gives you minus 2. The advantage of it is b instantly becomes 0, giving us the value of a. So we get a as minus 2 over here. Next, you put x as minus 2. The advantage of it is a instantly will become 0 and you will get the value of b, and that is minus b. That gives you b equal to 4. And once you get a and b, you may then write the integral, and the integral will be a, which is minus 2 upon x plus 1, b, which is 4 upon x plus 2 dx. Now minus 2 log x plus 1 will be the derivative of first term, plus 4 times log of x plus 2 will be the second term, plus c. This will be your answer. Now let us look at this quadratic polynomial, children, and in this quadratic polynomial, please observe that the denominator cannot be factorized by splitting the middle term. When the denominator cannot be factorized using the middle term splitting method, then what we will do is we will resort to our method of rewriting the numerator, which is 5x minus 2 over here, as a into the derivative of denominator, which is going to be 18x plus 6 plus b. And by comparing the coefficients of x and by comparing the constant terms on both the sides, we will find the value of a and we will find the value of b, and then we split and move further. I have also tackled this in one of my shorts, as well as in this section itself there was a quadratic polynomial which was under the root, and we had used this method. Following the same method, you can proceed further and get the answer. The point that I would again reiterate over here is observe that in first the denominator was factorizable like this, whereas in the second one the denominator cannot be factorized as x minus a into x minus b. In that case, this method will be adopted. When there is a root in the denominator, then there is no question of factorizing the quadratic polynomial like this. Definitely then this method itself will be used, writing the numerator as a into derivative of denominator plus b when there is a root. I am reiterating, when root is not there, then only we will check whether our quadratic polynomial can be factorized or cannot be factorized and use the correct approach accordingly. Now In this third question, which is also a very important PYQ, you can observe that one of the factors is x square plus 1, which cannot be factorized further, and one linear factor is this. The nature of partial fractions for this we had seen is we are going to write x upon x square plus 1 into x minus 1 as a upon what the linear factor was plus bx plus c upon what the quadratic polynomial which cannot be factorized was. Note here that when the denominator is quadratic, its numerator will have two constants. It cannot have one constant. That is the reason we write as bx plus c. Now what we will do is we will compare the numerator x to a into x square plus 1 plus bx plus c into x minus 1. And what we do next is we put x as 1. By putting x as 1, directly value of a will be obtained. 2a is what we get over here, which will give me a as 1 by 2. Next what we are going to do is we will put x as 0. As you can clearly see, there is a bx. पहले हमने x को 1 क्यों लिखा था? क्योंकि यहाँ पे x minus 1 एक फैक्टर था. तो जब ये फैक्टर है x minus 1, तब x को 1 लिखना है. नेक्स्ट x इक्वल टू 0 हम ले सकते हैं, और जब हम x को 0 लेंगे तो लेफ्ट साइड में हो जाएगा 0, राइट साइड में आपको सिर्फ यहाँ पे a मिलेगा. 0 plus 1 plus b into 0 हो गया, और c into 0 minus 1 is this. We have already got the value of a over here, and this equation gives us a equal to c. And because a is equal to c, therefore c will also be equal to 1 by 2. Once we obtain this, children, clearly we have gone out of, we are not left with any factors over here for x. So what we will do is we will choose our own value. It can be anything, and we will take the easiest one, x as minus 1. When we put on both the sides, we will get minus 1 is equal to a into minus 1 ka square plus 1, so 2, plus b into minus 1 will give you a minus b, plus c into you will get minus 2, which makes it minus 1 equal to 2a. Then you further have plus 2b, and then you will have minus 2c. We have a and c की value already, which makes it minus 1 equal to 2 into half plus 2b minus 2c is 1 by 2. You can cancel this, and this also gets cut, and eventually it gives you minus 1 by 2. You can calculate for yourself. Whenever you are attending a maths class, I always suggest that please keep a register, pen, pencil along with you, and you do the calculation simultaneously. That will not only keep you attentive, it will be helping you in understanding the topic better. So you have a 1 by 2 into x minus 1 over here, plus you have a bx, which is minus half x, plus c, which was a half, upon x square plus 1. Clearly the integral has been split into two parts. First part we will call as I1, and the second part we call as I2. In the first part, it is quite integrable already, so we will integrate it. We'll write 1 upon 2, and integral of this term is log of mod of x minus 1. Now let us see what is to be done with I2. Coming to I2, we can take a half outside, or maybe a minus half also can be taken outside, and then what remains, let us see what we can do out of that. So first what I'm going to do is I'm going to show with a different color over here. Minus half I've taken out, which makes it as x minus 1 upon x square minus 1. The advantage over here is, children, observe the denominator polynomial. In the denominator polynomial, there is a missing x term, means the denominator is already in the form of x square minus a square. In this case, what will work is we can further write this as x upon x square minus 1 and minus 1 upon x square minus 1. That makes it easy to integrate, and then put an integral sign over here. There was a minus half preceded by a half log x minus 1. Now what happens is, in the this integral, if you take this one as t, the denominator as t, then as a result of that you will have 2x dx equal to dt, and this can be worked out. And the second part of the integral I2 is directly integrable. It is in the standard form discussed in the previous section. So now we can write the integral carrying forward this first term minus half. Here if you take this 2 on the right hand side, it will become 1 by 2 dt by t, whose integral is log mod t, and t is what? X square minus 1. By now you should have been very clear in integration process, and remember that this minus 2 is getting multiplied over here. Don't forget that minus 2 to bring inside, and when you bring that inside you will have a plus 1 by 2, and the denominator is in the form of 1 upon x square minus a square, which is 1 by 2a, a being 1 over here, and log of x minus a upon x plus a plus c, and that is your answer. I will state here that wherever it is possible to combine the log terms very easily, there we are going to combine, and where it is not possible, the coefficients are varying and are different, we will not be combining. Here it is quite possible to combine because this is also going to be 1 by 4, this is also going to be 1 by 4, and you can split x square minus 1 as x minus 1 into x plus 1. I suggest that you take a 1 by 4 outside and then you combine these terms. Further, you can also combine the first term by taking a 1 by 2 outside, and then you can express the final answer. Next, in this integration by partial fractions, we have this topic wherein it's a very important PYQ. You have all these x squares. The fourth one is a very special one. What we will do here is this x square, for time being we will call it as y, like we will nickname it as y. After putting this as y, what we will do is this function which is given to be integrated will become y plus 1 into y plus 2 divided by y plus 3 into y plus 4, and then we are going to multiply it to get it as y square plus 3y plus 2, and the denominator will become y square plus 7y plus 12. And clearly the numerator and denominator are of same degree. When they are of same degree, we are going to divide the numerator by the denominator and rewrite it using division algorithm. So instead of 3y, we will write it as 7y plus 12, and then write down what is balance. Because it was 3y, यहाँ पे आप लिखोगे 4y, यहाँ सिर्फ प्लस 2 था, तो फिर आपको माइनस क्या कर देना पड़ेगा यहाँ पे 10. अगर आप अब न्यूमरेटर को देखो तो इसका फाइनल रिजल्ट स्टिल क्या हो जाएगा, y स्क्वायर प्लस 3y प्लस 2 ही रहेगा. अब डिनोमिनेटर को आप लिख लीजिए एज y स्क्वायर प्लस 7y प्लस 12. इसके बाद हम इनको सेपरेट कर लेंगे. जब इन्हें सेपरेट करेंगे तो हमें मिलेगा 1 माइनस 4y प्लस 10 अपॉन ये जो बच्चों फैक्टर है, ये वाला जो पॉलिनोमियल है, ये हमें y प्लस 3 इंटू वाई प्लस 4 करके ही मिला था. नेक्स्ट हम क्या करेंगे, इस वाले पार्ट को हम लिखेंगे एज a अपॉन y प्लस 3 प्लस b अपॉन y प्लस 4, और फिर हम फाइंड कर लेंगे a और b की वैल्यू को. जब आप a और b की वैल्यू को फाइंड कर लेंगे, उसके बाद आप y को वापस से x स्क्वायर पुट करेंगे और फिर आगे बढ़ेंगे. तो जो भी यहाँ पे वैल्यू आएगी आपकी, आप उसकी जगह पे लिखोगे 1 माइनस a, जो भी a आया हो बच्चों, अपॉन y की जगह पे आप लिख लोगे एक्स स्क्वायर प्लस 3. ये माइनस साइन अंदर ट्रेवल होगा, इसलिए ये बन जाएगा माइनस b, जो भी आपकी वैल्यू आई होगी सिंप्लीफाई करके, अपॉन y यानी कि एक्स स्क्वायर प्लस 4. अब आप क्लियरली देख सकते हो कि यहाँ पे ये सारे के सारे टर्म्स इंटीग्रेबल हैं. तो ये डिनोमिनेटर 1 अपॉन ए tan इनवर्स x by a की फॉर्मेट का है. सो यू विल बी writing this answer over here as x minus that a. Children, I am now reiterating that you have to find a and b yourself. That's a task for you. A into, you will have a 1 by a, which is 1 by root 3, and tan inverse of x by root 3, and then minus b 1 by a, here it is because 4, so a will be 2 tan inverse of x by 2 plus c, and that is your final answer. This is asked very often again in the board exam for 5 marks. The next one is also a PYQ, and the reason for them writing alongside is very important, and it is with purpose. It's not just I have written these two questions side by side. These two questions are written side by side so that you can compare the similarity yet the not similarity of them. Now often when we look at this procedure of question number 4, there may be a confusion of how to go about in question number 5. There is a minor difference in question 4 and 5 which will make the entire strategy used in question number 5 different. Notice that in numerator of question number 5 there is 2x, and 2x happens to be denominator of x square. So in question number 5 we are going to let x square be equal to t, and when you let x square equal to t you will get 2x dx equal to dt, and the substitution is going to work over here. Our integral will become integral of dt upon t plus 1 into t plus 3, and then this can be done by using a upon t plus 1 plus b upon t plus 3 very easily. We have seen many such solutions. Now look at this एक्स स्क्वायर को यहाँ पे जब मैंने टी लिया तो बेटा ये सब्सटीट्यूशन था, इसलिए इसको लिखा 2x dx इक्वल टू डी टी, जबकि मैंने यहाँ पे जो एक्स स्क्वायर इक्वल टू टी नहीं लिया, y लिया। यहाँ पे y लेने का पर्पस बच्चों यही था कि आप ये डिफ्रेंशिएट कर सको कि ये जो y था हम इसे थोड़ी देर के लिए, यानी कि आई से इट say it means call it as y for some time, इसकी वजह से dx dy में नहीं बदला है, जबकि क्वेश्चन नंबर 5 में dx dt में बदल गया है क्योंकि x स्क्वायर को t लेना यहाँ पे सब्सटीट्यूशन था. I hope you have understood this difference over here. Next, in integration of partial fractions, when we continue, you can see that sometimes we will come across questions where the degree of numerator is either equal to the degree of denominator, or sometimes it may be greater than the degree of denominator. So you have to take this note down, that if degree of numerator polynomial is greater than or equal to degree of the denominator polynomial, then first we divide the numerator by the denominator and rewrite using the division algorithm. Just now in the previous question 4 we had done the similar procedure. Now this is a very famous PYQ, children. We are going to proceed it in a manner that when degree of numerator and denominator is same, then how are we going to go about it? So when the degree of numerator and denominator is same, here the numerator is 1 minus x square. I will do one thing, I'll write it in the descending order of the powers of x. So this is my numerator. When I multiply the denominator, I get a x minus 2x square, and writing it as minus 2x square plus x. Let us see what will match over here. You will have to multiply it 1 by 2, which makes it minus x square, plus 1 by 2 x over here aside we will write minus, and this becomes plus. Cancel this. Taking it down, you have a minus half x plus 1, which is the remainder. That means that the divisor can be written as, not the divisor, my bad, the dividend can be written as, the dividend which is x square plus 1 will be written as 1 by 2 into the divisor plus the remainder. So we are going to rewrite our numerator over here as 1 by 2 into minus 2x square plus x plus minus half x plus 1 divided by, this is again a minus 2x square plus x only dx. Upon doing this, then we are going to group this and separate it. Now when we separate, what we get is, taking this half outside, minus 2x square plus x upon minus 2x square plus x is what we get, dx plus integral of, you get a minus half x plus 1 upon, you have a minus 2x square plus x dx. Children, clearly this term is getting cut and you will just get 1 in its place, which is quite integrable. Now come to this part. This part has now become a linear upon a quadratic whose factors are x and 1 minus 2x. You can write it as a upon x plus b upon 1 minus 2x. Proceed further to find a and to find b, and then split and integrate easily. Children, sometimes the questions will involve multiplication of one type of function with another type of function. Then in that case, what we call as integration by parts method will be applicable. The rule which we call as multiplication rule in differentiation, its name changes to integration by parts in integration. Integration by parts is the multiplication rule for the integration. So when a function u is multiplied to a function v, then its integral will be the first function u into integral of second minus integral of the derivative of first multiplied by the, here it should be integral of second. That is what the rule of by parts says. So we will lock this, and we will do questions like this by using the integration by parts method. Now clearly observe that it is product of x, which is an algebraic function, and sin x, which is a trigonometric function. Now it is a catch for us to decide which function should be named as first function and then which function should be taken as second function. Does it matter or does it not matter? But it definitely matters that which function do we take as first function and which function is to be taken as second function before we start our process of by parts. So for easy remembering of which one should be taken as first function and which one should be taken as second function, we rely on this acronym of ILATE, where I stands for the inverse trigonometric function and L stands for the logarithmic function, A stands for the algebraic function, T stands for the trigonometric function, and then E stands for the exponential function. Alright, so the first come first. Here you can see that algebraic comes before trigonometric, therefore this will be the first function and sin x will be the second function. Let us apply this rule here to integrate it. So it is first function, which is x, into integral of second sin x dx minus integration of the product of the derivative of first into integration of the second function. Dx will be written outside. So that will give you x into integral of sin x is minus of cos x minus integration of derivative of x is 1 and its integral is minus cos x dx. We are then just one step away from our answer. X cos x minus into minus becomes plus, and integral of cos x is sin x plus c. That is the answer. Now the next one is x into cos inverse of x. Now cos inverse of x is not trigonometric but inverse trigonometric function, and we can see here in our acronym that we have used that inverse trigonometric function comes first and then comes the algebraic function later, meaning that ये जो cos inverse x है इसको हम first function लेंगे और इसको हम लेंगे second function, and then we will proceed. So let us proceed in that manner. The first function, which is cos inverse x, into integral of the second function minus integration of the derivative of cos inverse x into the integration of x dx, and outside also there will be a dx. Now cos inverse x into integration of x, children, is x square upon 2 minus integral of cos inverse x का जो derivative होगा वो होगा minus 1 upon under root of 1 minus x square into you will have x square by 2 dx. Now we will proceed it further. तो हमें मिलेगा x square by 2 को आप पहले भी लिख सकते हो, फिर लिख सकते हो cos inverse of x, minus into minus is going to this, minus into minus will become plus, and you will have integral of x square upon, there is a 2 which I will write outside, and you will have a under root of 1 minus x square dx over here. So what we will do here is we will do a मैनिपुलेशन. यहाँ पे इसको माइनस एक्स स्क्वायर कर देंगे, उसकी वजह से ये साइन यहाँ माइनस हो जाएगा और हम अपनी ही तरफ से 1 को ऐड कर लेंगे और सब्ट्रैक्ट कर लेंगे. फिर हम इसे एक यूनिट मान के और इसे एक यूनिट मान के इसे कर लेंगे सेपरेट. सो यू विल हैव अ एक्स स्क्वायर अपॉन 2, यू हैव अ cos inverse x, then you have a minus 1 by 2 integral of, when these two terms are divided children, it will give you a under root of 1 minus x square minus 1 upon under root of 1 minus x square dx. And then these both are standard integrals. You know the formula of integral of root of a square minus x square, and you also know the formula of 1 upon under root of a square minus x square. Applying that, you are going to get the answer of this integral. Next, here you have x into cos inverse x divided by root of 1 minus x square. Here the two methods will merge. One of it is that you will let cos inverse x as t first, because we can see in the picture there is a function and then there is its derivative also present over here. So we will first do substitution, and after doing this substitution our integral then becomes, ये minus sign जो यहाँ पर आया है ये यहाँ लग जाएगा इधर, और फिर हम बाकी सारे terms को कर लेंगे adjust. जब हम cos inverse x को t लेते हैं तो x क्या बन जाता है cos t, तो ये बन गया cos t into cos inverse x को हमने लिया था t, और ये dx अपॉन रूट माइनस एक्स स्क्वायर बना था माइनस dt. माइनस हम ऑलरेडी बाहर पाक कर चुके हैं और हमने लिख लिया यहाँ पे इस इंटीग्रल को. अब क्लियरली जो हमने फर्स्ट इंटीग्रल किया था x sin x, ये उसी की तरह रिजेंबल कर रहा है. तो हम इसमें t को लेंगे फर्स्ट फंक्शन और cos t को हम लेंगे सेकेंड फंक्शन, क्योंकि एल्जेब्राइक पहले आता है, ट्रिग्नोमेट्रिक बाद में आता है. तो इसे फर्स्ट और सेकेंड फंक्शन लेके वी कैन प्रोसीड फर्दर एंड फाइंड अवर answer. Now integration by parts is a very important tool for finding integrals of sin inverse x, which we do not know so far. What is integral of tan inverse x? हमें नहीं पता क्या होता है. तो ऐसे फंक्शंस में जिनमें कि हमें ना तो अब तक इनके फॉर्मूले पता थे, तो हम इनको कैसे इंटीग्रेट करेंगे बच्चों? हम इनको इंटीग्रेट करेंगे इनटू 1 का प्रोडक्ट लेके. ऐसे ही हम साइन इनवर्स एक्स इंटू 1 लिख सकते हैं, इसे tan इनवर्स एक्स इंटू 1 लिख सकते हैं, और साइन इनवर्स को फर्स्ट फंक्शन और 1 एक पॉलिनोमियल है ऑफ डिग्री 0, इसलिए 1 होता है एक अलजेब्राइक फंक्शन. इस ऐसे प्रोसीजर यूज़ करके बाई पार्ट्स के मेथड से हम साइन इनवर्स एक्स का इंटीग्रल फाइंड करने में भी अभी सक्षम है. tan इनवर्स एक्स को इंटू 1 लेके इसका इंटीग्रल फाइंड करने में भी अभी हम कैपेबल हैं. और सिर्फ log x का बच्चों कोई इंटीग्रल अब तक हमें पता नहीं था क्या होता है, दैट इंटू 1 ले लेंगे. तो फिर हम डिसाइड कर लेंगे कि फर्स्ट फंक्शन किसको लेना है, सेकंड किसको लेना है. ILATE होता है तो लॉगरिथमिक फर्स्ट होता है, अलजेब्राइक बाद में आता है, तो लॉगरिथमिक फर्स्ट फंक्शन हो जाएगा. 1 को हम सेकंड फंक्शन लेंगे और फिर से हम बाई पार्ट्स का मेथड यूज़ करके इस तरीके के सारे इंटीग्रल्स का आंसर बाई पार्ट्स दे देता है आपको, उससे हम सॉल्व कर लेंगे. अब ये जो क्वेश्चन है बच्चों, इसे आपका कतई भी इग्नोर करके अपना बोर्ड एग्ज़ाम देने नहीं जा सकते. ये एक बहुत ही ज़्यादा इम्पॉर्टेंट PYQ है और ये सारे रिफ्रेशर्स में मौजूद है, सारे सैम्पल पेपर्स में मौजूद है, और हर साल के PYQ में ये पक्का आपको मिलेगा. तो इसको आप कैसे सॉल्व करेंगे हम देखते हैं. यहाँ पे ना हम एक बहुत ही स्पेशल टेक्निक का इस्तेमाल करने वाले हैं. तो वो स्पेशल टेक्निक ये है कि इस इंटीग्रल को हम फर्दर लिखेंगे एज log ऑफ log x dx प्लस हम फिर से लिखेंगे 1 अपॉन log x का होल स्क्वायर dx. तो हमने इसको दो पार्ट्स में ब्रेक कर लिया, ये है I1 और ये है I2. अब बच्चों यहाँ टेक्निक जो यूज़ होगी वो ये है कि हम I2 को कर लेंगे फ्रीज़ करने का मतलब है इसे ऐसे के ऐसे, ये हिलेगा डुलेगा बिल्कुल नहीं, इसको हम आगे 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 कैरी फॉरवर्ड करते रहेंगे, इंटीग्रेट नहीं करेंगे हम I2 को. ऑलराइट, हम सिर्फ I1 को इंटीग्रेट करने वाले हैं. तो अब ये जो I1 है ना बच्चों, ये log ऑफ log x दो अलग फंक्शन नहीं है। देखो log ऑफ log x एक ही फंक्शन है, ये एक कंपोजिट फंक्शन है log का खुद के साथ। सो log ऑफ log x को प्रोडक्ट ऑफ टू फंक्शंस नहीं ट्रीट करेंगे, इट इज़ वन सिंगल फंक्शन। सो इफ दिस इज वन सिंगल फंक्शन, टू प्रोसीड वी विल नीड टू मल्टीप्लाई इट बाय 1। सो इसको यहाँ पे इंटू 1 मान के जब हम चलेंगे, सो 1 हमारा बन जाएगा सेकेंड फंक्शन और log हमारा बन जाएगा फर्स्ट फंक्शन। सो I1 में हम इसे फर्स्ट फंक्शन और इसको सेकेंड फंक्शन 1 को मानते हुए आगे बढ़ेंगे, तो हमें इसका इंटीग्रल मिल जाएगा फर्स्ट फंक्शन विच इज़ log ऑफ log x इंटू इंटीग्रल ऑफ सेकेंड विच इज़ 1, और 1 का इंटीग्रल बच्चों होता है x माइनस इंटीग्रेशन ऑफ log ऑफ log x का जब आप डेरिवेटिव लेंगे तो आपको मिलेगा 1 अपॉन log x, फिर चेन रूल का इस्तेमाल करते हुए इस अंदर वाले ये log ऑफ log x का पहले बना 1 बाई log x, फिर इस log x का इंटीग्रल बन जाएगा 1 बाई x। इनटू आगे बढ़ेंगे तो इस 1 का हमें इंटीग्रल लेना पड़ेगा जो कि होता है x, फिर यहाँ पे लिख लेंगे dx। अब जो हमने इसको फ्रीज किया था एज इट इज़ कॉपी कर लेंगे, हमें इसे टच ही नहीं करना है। then this x and this x will get cut। अब हमारा ये जो आ गया है इंटीग्रल, इस इंटीग्रल में भी आगे बढ़ने के लिए हमें फिर से बाई पार्ट्स का इस्तेमाल करना पड़ेगा, और 1 अपॉन log x जो है उसको हम फर्स्ट फंक्शन ट्रीट कर लेंगे 1 अपॉन log x को, और 1 अपॉन log x को 1 से मल्टीप्लाई मान के हम आगे बढ़ेंगे, प्लस ये जो फ्रीज हुआ था इसको ऐसे ही फ्रोज़न हम लिख लेंगे और आगे बढ़ेंगे। अभी ये फर्स्ट फंक्शन की तरह ट्रीट होगा और 1 जो है ये सेकेंड फंक्शन की तरह ट्रीट होगा। सो बाई यूजिंग बाई पार्ट्स वंस अगेन ऑन दिस इंटीग्रल, you will have the first function which is 1 by log x into the integral of second which is x. Don't forget there was a minus sign, minus and then minus will make it plus, and the integral of 1 upon log x। बच्चों 1 upon log x पे अगर आप चेन रूल लगाएंगे तो इसका इंटीग्रल हो जाएगा -1 upon log x का होल स्क्वायर, फिर चेन रूल की वजह से log x के डेरिवेटिव से भी आपको मल्टीप्लाई करना पड़ेगा, मल्टीप्लाइड बाय ये जो एक यहाँ पे 1 है, ये 1 इसके इंटीग्रल से अब हम आगे मल्टीप्लाई करेंगे जो कि होता है x dx। ये x और ये x बच्चों यहाँ पे कट जाएगा। अब ये जो फ्रोज़न इंटीग्रल था इसे हम यहाँ कॉपी कर लेंगे। अब आप देख सकते हो कि ये जो फ्रोज़न इंटीग्रल था और ये टर्म जो यहाँ पर हमें मिली है, दे आर बोथ सेम, and because they both are same we can then cancel minus of this and plus of this। Can you see the beauty of it? That is why the second term was frozen, it was not supposed to be integrated। If we keep integrating the first and the second, both of them simultaneously, we are not going to arrive anywhere। You have to remember one key step over here is the freeze part of I2 which has to be frozen, and then we proceed। So what is left, children, add c to it, that is the answer to this integral। As soon as this class ends, please do this integral on your own, I suggest। Then in integration by parts we have this type, please do not forget to do this type before you go for your exam, and 1 mark question or a 2 mark question, sometimes a 3 mark question of this type, the second question type, can also be asked in the board exams। So what type it is when a e raised to x is multiplied to a function fx plus its derivative f dash of x, then you just need to identify it is this type, and its answer directly is e raised to x into f of x plus c। I have dealt with this type and its various questions in one of my short videos, please watch that। It has got all the possible questions that can be asked on this type, all। इससे अगर आप वो शॉर्ट वीडियो को देख लोगे तो कोई ऐसा आपके पास PYQ नहीं बचा होगा जो इस फॉर्मेट का आप ना सॉल्व कर पाए बोर्ड एग्जाम में, तो आप प्लीज़ उसको डेफिनेटली रेफ़र कीजिएगा टू सॉल्व मोर क्वेश्चंस ऑफ दिस टाइप। सो क्योंकि इसका आंसर ये हो जाएगा डायरेक्टली बच्चों, तो ये जो फर्स्ट क्वेश्चन मैंने यहाँ पे लिखा हुआ है इसमें आप आइडेंटिफाई करो कि tan x अगर फंक्शन है तो उसका डेरिवेटिव है sec स्क्वायर ऑफ x यानी कि f डैश x। तो आपका आंसर आ जाएगा e raised to x into fx, which is 10x plus c, and this makes it a 1 mark question. Whereas in second we have lots of to do, so this can be asked for either 2 or for 3 marks. So what strategy will we apply over here? Observe the denominator, it is 1 plus x, जबकि न्यूमरेटर में केवल x है. So केवल x अगर है तो उसे हम 1 से ऐड कर सकते हैं. ऐड करेंगे तो बैलेंस करने के लिए हमें सब्ट्रैक्ट भी करना पड़ेगा. और फिर मैंने ये बार लगाई है, मतलब ये सेपरेट अगर हम करेंगे न्यूमरेटर अपॉन डिनोमिनेटर तो ये उसकी टेक्निक है, इंटू ई रेज टू एक्स डी एक्स. अब हम इसे 1 यूनिट कंसीडर करते हुए और इसे 1 यूनिट करते हुए इसके अपॉन डिनोमिनेटर लिख लेंगे और इस 1 के अपॉन इस डिनोमिनेटर को लिख के सेपरेट आउट कर लेंगे. तो उससे हमें मिलेगा 1 प्लस एक्स अपॉन 1 प्लस एक्स का होल स्क्वायर माइनस 1 अपॉन 1 प्लस एक्स का होल स्क्वायर बाहर ई रेज टू एक्स डी एक्स. अब अगर आप इसे कैंसिल कर लेंगे तो यहाँ केवल ये बच जाएगा. अब जब ये बचेगा तो आप क्लियरली देख सकते हो कि अगर आपका फंक्शन है 1 अपॉन 1 प्लस एक्स बचा यहाँ पे और इसके साथ में माइनस 1 upon 1 plus x का whole square ex dx. Children, if this is f of x, then clearly minus 1 upon 1 plus x square is f dash of x, making it resemble exactly to this type. And because it is now resembling this type, we can now write its answer, and its answer will be e raised to x into what is fx, 1 upon 1 plus x plus c. This is all about all the different methods of integration I dealt with in part 1, 2, 3, and this is the fourth and the final part. Make sure that you practice a few of the problems right after this class. If this video has helped you understand integration better, then please drop a like, share it with a friend who is stuck on integrals, and subscribe for more maths videos. See you in the next one. All the best.